Right, in our practice book, our homework last night was 35 through 38. This is comparing numbers in scientific notation. This is the ones where they wanted you to find out how many times more a number was. Study the example problem showing how to compare two numbers written in scientific notation and then solve 1 through 7. The example is talking about the area of Rhode Island and the area of Georgia, and they are comparing these using standard form, and then they're comparing them in scientific notation. Remember, we talked about there being two strategies for solving these problems. This is your two strategies. Number 1 says, which of the two methods shown in the example problem do you prefer? This is just an opinion question. You really can't be wrong here. You just look at them and decide which you prefer. For this problem in particular, 60,000 divided by 1,500, I would probably use standard form for that one, just because the numbers aren't so big that they're not easy to work with. But if those numbers were bigger, I would have probably preferred the scientific notation. With the problem given to me in scientific notation, I doubt that I would have converted it. I probably would have went with scientific notation. So on number 1, you just had to pick one and then tell me why. Okay, this was your opinion. Whatever your opinion was on that one. Number 2 says the total area of Ohio is about 4.5 times 10 to the 4th square miles. The total area of Ohio is about how many times the total area of Rhode Island? If you know anything about Rhode Island, you know it's fairly small by comparison to the other states. Now, they didn't give you the number for Rhode Island, but if you read the example problem, Rhode Island was given to you. Now, when they say how many times is Ohio than Rhode Island, that means you're going to set this up as division with the larger state, Ohio, divided by the smaller state, Rhode Island. So in my numerator, I'm going to have Ohio, 4.5 times 10 to the 4th. I'm going to divide it by Rhode Island, which was 1.5 times 10 to the 3rd. Now, when we divide, we are going to divide the constants. 4.5 divided by 1.5 is 3. Then we're going to divide the base 10s, and we use the quotient rule for that. 10 to the 4th divided by 10 to the 3rd is 10 to the 4 minus 3, which gives us 10 to the 1. Now we wanted to know how many times greater Ohio is than Rhode Island. In scientific notation, that doesn't tell us much, but if we change it to standard form, by making 3 one place value bigger, it becomes 30, and 30 times is a number we're comfortable with. Okay, Ohio is 30 times the size of Rhode Island. Number 3, which is greater, 9 times 10 to the negative 2 or 3 times 10 to the negative 4? How many times greater is the number you chose than the other number? Explain your reasoning. Now you've got to keep in mind with negative exponents, we're talking about numbers that are smaller than 1. The more negative exponents you have, the smaller that number is going to be. I really feel like 3 times 10 to the negative 4 is going to be the smaller of those two numbers. So I am choosing 3 times 10 to the negative 4. If I wanted to be certain, I could put those in standard form. I would have 0.09 versus 0.0003. 3 times 10 to the negative 4 is smaller. That's not what they asked me for. They asked me which is greater. The greater number is 9 times 10 to the negative 2. Now, when we divide, we put the big number on top, the small number on bottom. So the greater number, 9 times 10 to the negative 2, divided by the smaller number, 3 times 10 to the negative 4. We're going to divide, doesn't change anything just because those exponents are negative. We're just going to do the same thing we always do. 9 divided by 3 is 3 times, and then we've got 10 to the negative 2 divided by 10 to the negative 4. So we're going to minus a negative 4, and two negatives make a positive, giving us negative 2 plus 4 is 10 squared. That doesn't mean much, but when I make it 2 place values bigger, my 3 becomes 300. So it is 300 times greater than 3 times 10 to the negative 4. 4. The total area of Kansas that is covered by water is about 5 times 10 to the 2 square miles. The total area of Alaska that is covered by water is about 9.5 times 10 to the 4th square miles. The total water area of Alaska is about how many times the total area of Kansas? They're telling you in the wording that Alaska has more water coverage than Kansas. They want us to decide how many times more. So we're going to put Alaska on top, 9.5 times 10 to the 4. We're going to divide that by Kansas, which is much smaller. And then when we simplify, we will know how many times more water is in Alaska. So 9.5 divided by 5, it doesn't go evenly. It's going to give us a decimal. It's going to give me, I think, 1.9. 45, yeah. 1.9 times, then I'm going to divide my base 10s. And I do that using the quotient rule. 4 minus 2 gives me 10 squared. Now when I put it in standard form so I can actually comprehend the number, I'm going to make it 2 place values bigger. So 1.9 will jump to 190 times. Okay. Alaska has a lot of water coverage. Number 5, the average masses of several insects or animals are shown in the table. The average mass of a hummingbird is about how many times the average mass of a housefly? Now, we're talking about some really tiny creatures here. Okay, a hummingbird is little. A housefly is even smaller. So they're telling you that the hummingbird is larger. So we've got bird divided by fly. The bird is 3.6. The fly is 1.2 times 10 to the negative 2. Now, for the first time, you're seeing a number where one is in scientific notation and the other one is not. Now, that bird is really easy to fix. We're going to give it a base 10. Did we have to move the decimal place to make 3.6 correct? We did not. That means we shifted 0 decimal places. So just give your base 10 a 0. It doesn't carry a value, and now both of your numbers are in scientific notation. Then we're ready to divide. We've got 3.6 divided by 1.2, which is 3. And then when we divide our base 10s, 10 to the 0 divided by 10 to the negative 2 is going to give me, I'm going to subtract a negative 2, it's going to give me 10 squared. So a hummingbird, I'm going to increase this by 2 decimal places, is 300 times the size, the mass of a housefly. Look at the table in problem 5. Write the masses of the ant, the bee, and the housefly in order from the greatest to the least. Remember, I told you to always make sure you're getting the right directions. They want the biggest one to the smallest one. If you wanted to put these in standard form, you could. You've got, all of these are negative. Your largest negative exponent would be your smallest number. So the ant is going to go last. Our smallest negative exponent would be our largest number. So B would go first. And then the fly would go in the middle. Now they did say to write the masses. I guess I should have wrote the numbers. The B is 1 times 10 to the negative 1. The fly is 1.2 times 10 to the negative 2. And the ant is 4 times 10 to the negative 3. In standard form, the ant is 0.004. The bee is 0.0, no it's not, it's just 0.1. And the housefly is 0.012. So, scientific form or standard form, it's your preference. B says the mass of the insect with the greatest mass is how many times the mass of the insect with the least mass. We just said that the greatest mass was the bee, and the least mass is the ant. So you're going to divide bee by ant. The bee is 1 times 10 to the negative 1. The ant is 4 times 10 to the negative 3. Then we're going to divide. 1 divided by 4 is 0.25 times 10 to the negative 1 exponent, negative 3 exponent, negative 1 minus a negative 3 becomes plus, and we get 10 squared. That positive exponent, this is not correct scientific notation, just so you know, but we want to put it in standard form anyway, so it doesn't matter. I'm going to make it 2 place values larger, telling us it is 25 times greater. 25 times greater. Number 7, the population of the United States is about 3.2 times 10 to the 8th. The population of the United States is about 80 times the population of Oregon. Write the population of Oregon in scientific notation. Okay, so think about it this way. The United States is 3.2 times 10 to the negative 8, and it is 80 times the population of Oregon. Now, as an equation or a formula, you would have the United States is equal to 80 times Oregon. Okay, it is 80 times larger than Oregon. So if we substitute our values in, we would have 3.2 times 10 to the 8th is equal to 80 times Oregon. We're solving for Oregon. To get Oregon by itself, to isolate it, we're going to have to undo that 80 times, and we're going to have to divide by 80 on both sides, which will leave us with Oregon on the right. And we have to divide the numbers on the left. Now, the top one is a base 10, the bottom one is not. It's easy to fix, okay? We can just add a base 10, just give it a 10 to the 0. 10 to the 0 holds a value of multiplying by 1, which is nothing. Now, it's not in proper scientific notation, but we can still divide with it not being proper. So 3.2 divided by 80, and no, I don't know that off the top of my head, gives me 0.04. So 0.04 times 10 to the 8 minus 0 is 8. Now, it is not in proper scientific notation. We're going to fix that. Our positive 8, we need to move our decimal 2 places over. Well, I don't even need this answer in scientific notation, do I? I want to know the size of the population. So I just need to make it 8 decimal places bigger. So there's 1, 2 would give me 4 times 10 to the 6. So I need a 4 with 6 zeros.